Lesson 1.3, use distance and midpoint formulas. The learning target for today is to find lengths of segments in the coordinate plane. The midpoint of a segment is the point that divides the segment into two congruent segments. A bisector is a point, line segment, or plane that intersects the segment at its midpoint. So here, M is the midpoint of segment AB, so AM is considered congruent to MB. And CD, line CD, will be the segment bisector of segment AB. So we can say AM is congruent to MB. Example 1, find RS. So that would be the length from point R to point S. So we need to take 21.7 and double it. So that would be 43.4. Example 2, find AB. So these little markers here tell you that AC is congruent to CB. And the length of AC is 2 1/4. So CB should also be 2 1/4. So that gives you 4 1/2 for AB. Example 3. Point C is the midpoint of BD. Find the length of BC. So since BC is congruent to CD, because C is the midpoint, then BC should be congruent to CD. So I can set these two variable expressions equal to each other. So that would be 3x minus 2 equal to 2x plus 3. And to solve this, we should get x equal to 5. Example 4. Point K is the midpoint of segment JL. So this makes JK congruent to KL. Find the length of KL. So we would do the same thing. 8 minus 3x, set it equal to 2x plus 5, and solve for x. And then that we should be able to get 3 equal to 5x as the next step, and x would equal to 3/5. The midpoint formula. The coordinates of the midpoint of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. So if point A, x1, y1, and point B, represented by x2, y2, are points in a coordinate plane, then the midpoint M of segment AB has v coordinates mx, my. And to calculate mx, remember we want to take the average of the x coordinates. So that would be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And we put parentheses around them. Let's practice. Find a midpoint. The endpoints of segment PR are -2, 5, and 4, 3. Find the coordinates of the midpoint M. So we can take -2, add it to 4, and then divide by 2. The same thing goes for the y coordinates. 5 plus 3 and divide by 2. Then we should get 1, 4. Now the question could change a little bit, where you can be asked to find the endpoint when you're given a midpoint and another endpoint. So I'm going to call endpoint C x2, y2. And now I'm going to set up two equations. 3 equals 1 plus x2 divided by 2. So instead of calculating for the x coordinate of the midpoint, we're looking for the x coordinate of the missing endpoint. So after we solve for x2, you should get 5. And for the other one, we do the same thing. 4 equals 6 plus y2 divide by 2. And y2 should equal to 2. So your other endpoint, endpoint C, should be 5, 2. Example 6 is very similar to example 5. I would like you to take a couple minutes to solve them on your own, and then continue to play the video for the answers. Now check your answers. Now we have the distance formula. If point A, defined by x1, y1, and point B, defined by x2, y2, are points in a coordinate plane, then the distance between A and B is defined by this following formula. Example 7. What is the approximate length of segment RT with endpoints R 3, 2 and T negative 4, 3? So we just have to substitute these points into this formula. So I will let this be the first point and this be the second point. So I'm going to take negative 4 and subtract positive 3 and square it. I'm going to add it to the y coordinates. 3 minus 2 and then square it. And then we can go ahead and solve this. And further simplify this to 5 square root of 2. Now I would like you to pause the video and calculate example 8 on your own, and then continue the video for the answer. Now check your answer. We will continue the lesson in class.